Okay, so I'm going to go ahead and start the timer for you to have some time to complete the bell ringer in Schoology. And actually, what I want you to do is pause the video, go complete the bell ringer in Schoology, and then come back whenever you're done with that. So we are starting lesson 4, and it is about binary numbers. For your warm-up in your journal, don't forget to set up your warm-up the way that we do. Yesterday, you created your own number system using circles and squares. In your journal, I want you to come up with as many things as you possibly can to communicate. What can we communicate using only 2 symbols? Come up with as many things that we can communicate using only 2 symbols. Is there a limit? I'm going to start the timer so you'll hear the beep whenever it's over. I'm going to give you 3 minutes for this. Sorry, I have to change it. Okay, 3 minutes. Now, if you had somebody that you could discuss this with, you can go ahead and get with that person and talk about your answers. If you were in class, in about a minute, we would be sharing aloud. Okay. Okay, so I want you to set up your journal like this, where you have binary number, bit, byte, and then at the very bottom, put decimal. We would cut these out and glue them into our journals, but instead, we're going to just write them in there, and then you can count them as like headers. Don't forget to set up your journal. This is put whatever the date is that you're doing this activity, and then Unit 1, Lesson 4, and then this is the actual activity. And pause the video if you need a moment to do this, and we'll actually add these vocabulary words to a special vocabulary section also. So this might be a little bit repetitive. Okay, so today we are going to explore how binary numbers work. With only one place value, we only have two possible patterns, circle or square. I started with circle, but we could have easily started with a square instead. With two place values, we can make two sets of patterns. Then insert circles in front of the first set and squares in front of the second set. This makes 4 possible patterns. For 3 place value patterns, we can make 2 copies of the 2 place value patterns. Then, just like we did before, fill in the first set with circles in front and the second set with squares in front. This makes 8 arrangements. And just so you know, computer scientists like to start counting at 0. Okay, so store that bit of information away for later. So, when we're counting, we start at 0, even though there is a total number of 8. Because 0 counts as a number. So we end with number 7, but it's actually going to be like n plus 1. Okay. So if we have a total number of 10 things, when we count them, it'll be actually n minus 1. We won't have 10 as our last number. We would have n minus 1, 9. Okay. So instead of 2 shapes, what if we had 10 shapes? Okay, like I said, our n minus 1, 10 one-shape patterns. We could use more geometric shapes or we could use letters, but the shapes we are used to are the numbers 0 through 9. The numbers that we use are literally just shapes, okay? With 2 place values, we have 100 two-shape patterns. These are numbers 00 through 99. Now, what happens when we count up to the last shape? What number comes after 099? 100. Exactly. When we run up to the last shape, 9, we roll over. I'm going to go back over here. We roll over this number, and these 2 numbers go back to 0. This is the place value that we have used all of our lives. So where is this heading? You already know, binary. Okay. Binary is a number system with 2 shapes. Instead of shapes, we use zeros and ones. In this example, each pattern maps to a decimal number from 0 to 7. And that's these right here. These are the decimal numbers. And then these 3-digit numbers are the binary numbers. So for today's activity, you will be creating a flippy-do. Yes, the name is silly, but It's called that because we use the bottom pieces to flip and essentially create our binary number. Now, one thing that I want to point out before we get started on our flippy-do is yesterday y'all figured out that the equation for getting how many possible combinations was 2 to the nth power. So whenever we had 3 place values, we said 2 cubed, and that gave us 8 possible combinations. And so 2 to the 4th power was 16. And so we would say that by making the rule 2 to the nth power. So I am going to share a separate video on how to make the flippy-do, and I messed up a couple of times in this video, so I hope you enjoy watching it because it was humorous as I was making it a few years ago. And you will use a plain piece of paper, you'll need scissors, and then you'll need something to write with. So each place value represents 1 bit, which is short for binary digit. So if you can combine the B from binary and the IT from digit, you would get bit. A binary digit can be a 0 or a 1. Your flippy-do has 8 bits. And so if you count the spaces, 1, 2, 3, 4, 5, 6, 7, 8. It has 8 bits, which together make 1 byte. So when you're writing the definition in your journal, you can say 1 byte equals 8 bits. Since computers represent information digitally, the lowest level components of information are bits. All right, let's make our flippy-do. You're going to take a plain piece of paper, okay? You're going to fold it like this. So we're holding it landscape. Holding it landscape, bring the 2 edges together and make a crease. And I'm going to make sure that I don't mess up. Okay, still holding it, but we just did this. We're going to do it again. Fold it like this again. Okay, and then my apologies. Then we're going to do it again, okay? I have not changed the orientation of my paper once. Okay. There. If you have a boning tool, which is something that helps really make creases stronger, you can lay this down, and you can even use like the edge of your pencil or a pen and then just really push on it, and that will help really solidify those creases. Boning tools are used in like book binding and making your own books and stuff. Okay, so whenever you open this up, you should have 8 columns. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Now, we need to turn it portrait and make 3 columns. So I'm going to put the paper down so that way I can really make like the 3 columns. So bring one edge a little more than middle, 1/3, okay, bring it over 1/3, and then you're going to make that crease. Bring the other edge over the rest of the way, and it's okay if they're not all the same size. Okay, now you have 3 sections. Whenever you hold it landscape, you have 3 sections. For the bottom section, I want you to fold it in half. Just the bottom section. Top section, middle section, bottom section. So we have 2 equal sections, and then the bottom section is folded into 2 equal sections also. Put 2's all the way across, okay, because this is our base 2 section. I wrote it on my original one. So write something, get a pencil. Well, obviously you need a pencil for this part, okay? And now I have a clipboard. So you're just going to write 2's. The 2 to the nth power is what we want going all the way across the top section. And remember, we start at 0 because we're computer scientists. All right, so on the right side though, just like it is on the screen, 2 to the 0, and then 2 to the first power, 2 to the second, to the third, the fourth, the fifth, etc., all the way to 7. Now, and at the very top, I want you to put base 10. Put base 10 at the very top, so that way it's in this row, so that way you know, okay? Now, our middle area, put decimal, because these are our decimal numbers. 2 to the 0 power is 1, and that's what you're going to put. And then essentially, right below each 2 to the nth power, you're going to put what it equals. And that last number is 128, even though it looks like a 7. Now, on the very bottom, no, not the very bottom, the second to the last row is going to be zeros all the way across, because now these are our binary numbers. Then you're going to flip up that bottom row, and those are going to be 1s. Now, you have everything written. You need to get a pair of scissors, and you're going to cut this little slit so that way all of the 1s are separated. Okay. You want to be able to fold each one up individually. And you already have the creases as a guide. Okay? And this is your flippy-do. So make sure you put your name on the back or something, so that way if you leave it behind and it's not in your journal, then I know who to give it to. Okay. So with your flippy-do, let me get to the correct slide. I want you to use your flippy-do to represent the decimal number 7. How do we do that? Well, let's look at, we're going to start on the right side, which is different than how we read. In English, we start on the left side. So again, we're going to be different. The first thing I want to point out is 8 is more than 7. You know this. So that means we're not using the 8 column because that's already too much. So we have 4, 5, 6, and 7. I want you to think about the 0 place value. If there is a 0 there, that essentially means that the number is off. Well, we just added up 4, 2, and 1, and that equals 7. So we need to turn all of those on. So we would do this. The binary number, I'm going to fold my paper in half so that way we only see up to 8. The binary number for 7 is 0, 1, 1, 1. Now, what about 20? Well, let's look at our decimal. Okay, 16 is too few. 32 is too much. So we're going to stick with 16, okay? Because that's the closest number. So which numbers can we turn on to make 20? If we turn on 16 and we turn on 4, we have 20. So that gives us a binary number of 10100. Now, let's look at the numbers that are binary and see if we can determine what the decimal number is. Okay? So this 0 right here is the 2 to the 7th power 0. So I like to keep with the start on the left part, okay? So I'm going to start with this number, which is 2 to the 0 power. And that's a 0. The next one, the 2 to the first power should be a 1, and then a 0, 0, and then a 1. So that's 16, 17, 18. So the first binary number is actually the decimal number 18. Now, let's turn on the first 5 place values. Add up 16, 8, 4, 2, and 1. Because that's what we've got. 1, 1, 1, 1, 1, 1, 1. We've got 5 ones. The rest are zeros. So when we add those up, we get 31. And so that is how we can use this flippy-do as kind of like a binary calculator. So if you have questions about that, please let me know. What you're going to do now is use your flippy-do to answer and convert binary digits and decimal numbers. So in this first section, you're going to use all 4-bit decimal numbers. What's a 4-bit decimal number? It's the first 4. It's the first 4. So 2 to the 0 all the way through 2 to the 3rd power. Every number that comes in between there. So any number starting with 0 all the way up to the number 8. How can we, well, no, it's actually more than that. I'm sorry. So what you're going to do, this is, in case you don't recognize this pattern, 0, 1, 2, the decimal numbers are going to be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You're going to go all the way up to 15. What's the next? That's 16. All right, so the first 4-bit numbers get you all the way to 16. The first 5-bit numbers get you all the way not to 32, but to 31. Okay, so you're going to use your flippy-do to calculate the binary number for those decimal numbers in that first section, and then you're going to answer this question. Then in the second section, okay, you're going to look at this pattern. These are, we're going to use 8-bit decimal numbers. So look at this pattern. The first number we're turning on is 2 to the 0 power. That equals 1. We're turning that off and then turning on 2 to the first power. That equals 2. We're turning that off and turning on the third one, 2 to the second power. What does that equal? We're going to continue with this pattern, okay? And we're putting what their decimal number is. All right, so pause the video here and complete this part of the worksheet. And if you have any questions, send me an email. Once you get done with the front side, go ahead and flip it over and do the back side, and make sure that you're answering these questions, because sometimes these questions are so far at the bottom of the page that they're easy to miss. So pause the video to finish the worksheet, and you can submit it to Schoology if you are doing this digitally, or you can turn it into class if you're doing it in class. And then we're going to do our wrap up. So on our vocabulary canvas, we're actually going to create a special place in our journal for the vocabulary. Let me grab that. Okay, so in your bucket, you should have a blue rectangle, and you're going to create a special place for vocabulary. All right, you're going to start with the vocabulary word, use a shape or use some type of shape to help explain it. So what is a byte? We said earlier it's 8 bits. So you can just type 8 bits, or you can put something like 2 to the 7th power, just some type of visual to help you understand that. And then, no, JK, you're going to start with the definition, okay? So a byte is a unit of digital information that most commonly consists of 8 bits. It is the smallest addressable unit of memory in many computer architectures. Okay, that's a nice big definition for what I said earlier, which was 8 bits. Okay, we're not using that. We don't want that definition, we want your definition, because if you use that definition, you're less likely to actually remember it. So give the word byte a definition of your own that helps you remember what a byte is. All right, these are some options. 0 to 255, made up of bits. You could also use 8 bits. Those are all options. Okay, now we're going to continuously add vocabulary to our vocabulary canvas. Okay, and it's a work in progress. So as we learn new information, we can go back and we can add something like 8 bits. All right, what else can you add to make your design even more complete? If there is some type of visual that you can add, do that. And that's kind of like what we were going with on our first one. So this would be an example. We have 8 places right here, and then we have some binary numbers. Now, 8 bits, so the zeros, because they're off, they don't really matter if they come before the first one. So that's why there are no zeros right here, because they're almost irrelevant. I mean, they are irrelevant. All right, so these are some more options for visuals. If we were doing this digitally, you could literally add a picture of your flippy-do and do it that way. You can create an association between the word and something else that helps you to remember. Since byte sounds like the word bite, you could draw a mouth with 8 teeth if you're feeling very creative. Okay, a quick sketch. You can add a quick sketch. You can add a bad joke or a pun. You can make it an acronym. Okay, so byte could be bits you total to 8. All right, you could add a link or something else, you know, like another bad joke. Create a concept map by linking your canvas to explain the larger connection between vocabulary words and how they interact. That's going to be like this. Whenever you have like 1 or 0, you draw an arrow, and then we're not getting this in depth right now, but this is one way to create a concept map. Ultimately, a vocabulary canvas is designed by you in order to speak to you, because it's yours. It's meant to help you learn the vocabulary. As your understanding grows, so should your canvas. It's never too late to go back and add an interesting thought or an insightful idea. And we will use the Give One, Get One activity in class in order to share your creations with your classmates. So add these numbers, the same, not numbers, add these vocabulary words. You've got byte, bit, binary number, and also add decimal number. And I am going to give you those definitions if you want to use them as a reference for creating your own definition. A decimal number is a base 10 number with 10 possible different digits. This is a possible visual. This is a possible visual, okay? Binary number is a base 2 number with 10 possible different digits. This is a visual possibility. This is a visual possibility, okay? Pause the video here if you want to spend more time on this slide. A bit is a contraction of binary digit, the single unit of information in a computer, typically represented as a 1 or a 0. Okay? And then byte, 8 bits, and then you also have that incredibly long definition from earlier. So pause the video here if you want to use this slide more.